Nothing you're about to hear is my real voice. This voice is fake, so is this one, every word of it. That's my Mac talking, free, no account, no API key, fully offline. One open source tool, 6 minutes to set up, and I'll show you every step. 6 minutes, 5 steps. 1. What your Mac needs and how to check it in 10 seconds. 2. The setup, 1 folder, 1 install, 1 download. 3. Your voice, you record about 20 seconds and that's all you need to clone you. 4. Your first audio plus a quick check that every single word made it. And 5. The one most people get wrong, long audio without your Mac running out of memory. That's the whole video, let's start. So this is the tool that we're gonna use. So it's called .tts mlx. And when we see here already the MLX part, it means that it only works on MacBooks, but not all MacBooks, only the MacBooks that are not Intel, so only the M-chip ones. And what it allows you to do, it allows you to clone any voice from just a sample audio. It supports 24 languages and you can run it locally without any internet after you have it set it up. But before we start this, let's take a look into the requirements. So this is what you're gonna need before you start. So as I told you, you're going to need a MacBook with an M chip, so M1 or newer. You're going to need 12 gigabytes of free memory. So here we're talking about the RAM. And we're going to need 6 gigabytes of free disk space. So the model that we're going to use, it's already 2.4 gigabytes, plus the packages and some extra files related to it will end up being 6 gigabytes. If you don't know how to check this, you can install a plugin like this one, System Monitor, that allows you to see these fields. So here we have Apple M3 Pro, we have the memory part, so 17 gigabytes are being used of 36, so I still have the 12 gigabytes needed. And I also need the 6 gigabytes of free disk space. And I have 417 used, so I still have some space. Also, you're going to need the following tools. You're going to need Python 3.11, you're going to need FFmpeg, you're going to need Whisper. If you don't know how to check these tools, you can just open the terminal and you paste the following. Python 3.11 and then you pass the flag version. So this will check the version that you have of Python 3.11. If it doesn't work or it doesn't recognize the command, it means that it's not installed. And then we have the which, FFmpeg and Whisper that will show the path where these tools are installed. If it doesn't show the path, it doesn't find them, it means that they need to be installed. In my case, yes, I have Python 3.11.8, so I have it installed, and I have the path where these tools are installed. Another thing important to know is that these tools are free and they will work even if you don't have internet after you install them. After this, you just need to check if all 6 are there. If no, you need to fix that. And if yes, we can start. And with 6, we mean these 3 tools plus this. So we need M-chip, the free memory and free disk space, plus the tools. Now that you have everything set up, you can start your first audio step by step. So first, let's create a folder for it. So you can create it manually, but in our case, we're going to make a directory called .tts-demo, and then we're going to create these subfolders there. And we're going to go inside this folder. We can list what's inside, and we see the 3 folders that we expect to be there that we created here on top. We're going to create our virtual environment. We're going to activate it. And now, before we install the tool, we're going to make sure that we keep the model cache inside this folder. So for this, you're going to do the following. So you're going to run the following commands. Again, I'll leave this in the description. This created a inv.sh file, so we're going to run it, so using source. And now we're going to echo the variable hfhome. So this will tell us where the hfhome is. And as we can see, it's inside the folder that we created, the .tts-demo. So we are good to go. So let's install the tool. As of today, 12th of August, we have the last version that's 0.7.0, but what you should do is that you go to the official GitHub page and you go here on the releases and you check what's the latest one. So let's install it. While it's installing, one thing that you have to be careful, because if you go here, if you scroll a bit to the part where it says how to install it, you will see here it's pointing to the 3.1 and this is the stale version, it's not up to date. So make sure to go here on top and pick the latest one. So we see here on the right, it finished installing. Let's clear the terminal and make sure that everything is installed. So you can use the following command. And we see that Python, so it's installed in the virtual environment. We have the HF installed and we have .tts also installed. So we have everything to start except the weights. So let's download the weights. So the command to download is the following one. So we're going to use this HF tool to download it. And we're specifying where this model is and what to include. So we're going to include the int4 version and we're going to download it to the weights folder. The download completed, and we can see here, as expected, the 2.4 gigabytes for the model. Now we're going to go to the next step, is that we need to record the clone of our voice, or if we already have one, we're going to use this one. The recording, you should do 15 to 21 seconds, one continuous take. Longer sounds better, but it will cost memory fast. From experience, 21 seconds peaked at 34 gigabytes on this computer, but 14 seconds peaked at 22 gigabytes. So you can see a big difference just in a few seconds. If you want clean audio, one speaker, you don't want any music or any gaps in it. So when you see 20 seconds here, try to do between 15 and 21 seconds, with the idea that longer ones will sound better, but they will use a lot more memory than the shorter ones. Also, make sure to speak calmly if you want the pace to be copied also as a calm one, but if you want to be a rushed one, you can also generate a rushed audio soil. Because speed is cloned, a rushed reference makes every future line rushed, and speeding up or slowing down afterwards does not fix it. Make sure that it's a clean audio, one speaker, no music, and no gaps. And then you're going to need a transcript for this recording part. So for the transcript, it must match the clip word for word, and if you have a number, you need to spell it out spoken. So 87% and not 87% like a number. This will not work, you need to type it out. So in my case, I already have the reference voice, so I will just copy it, the reference folder, and also the transcript of it. I'll play it so you can hear how it sounds. So as you can see, it's just a text file, but a text file cannot compress anything by magic. The people that made this, they already admitted it. So the real number for me would be a bit higher than this 27%, but not close to the 65% advertised. As you can hear, this sample was not perfect. There was some gaps, but it will still work, as we're going to see. So now that we have our sample and we have the text of the sample, we can actually run our commands. So first is the tool that we are using, so the one that we installed. Then we have the model that we are using, the text that we want to generate to audio, and then we have our reference audio, the reference text, then we have the language. So in here, this does not identify the language automatically. You need to pick one of the 24 languages supported on this tool. Then we have the output path, the output prefix for the file name, and the seed. So this seed will make it so that every time you run the same command for the same inputs, you generate the exactly same audio. If you have some problems, you can play around with this seed, like change the value to see how it changed the output. Let's send this. It finished generated, and you can see here the MLX peak was at 34 gigabytes. If we passed a shorter voice reference, it would be less. So in here you have to play around with your use case. If you have more RAM, you can pass a longer one and you will have a better output. So let's hear the result. Okay, so this is my own voice running on my own laptop. No API key, no credits, no internet. It cost me nothing. Quick pause. The Build with AI Club takes you from zero to your first paid build with AI. No code. Your website's live by chapter 2, your first client by the end, and I'm in there helping when you're stuck. Try it free for 7 days. Links in the description. Okay, back to it. So this was the raw takeout, so the raw output. And in some cases, as we saw, we have some small silences in the audio. So in here, we're going to cut the silence. How to do this? I already have some scripts to do this, and I'll copy them locally. I'll also leave this in the description for you to download, and we're going to clean it up. So we're going to use the postpass.sh on this file. We can see that it went from 8 seconds to 7 seconds, so it cut some silence parts, and let's hear it again. Okay, so this is my own voice running on my own laptop. No API key, no credits, no internet. It cost me nothing. We could hear that the silence was gone, and we can go to the next step. Is that every word is there, and how can you check this? So again, I have a script that will help you check this. Also, I have a file locally with the words that were said that we can use to cross-check this. So we're going to do the following. So you're going to use the script verify take with output final. So make sure that you put the final here and the demo line. If you say, okay, word complete, it means that every word is there in the audio and it's safe to use in anything that you need. In the case that you don't see, okay, word complete, it means that not all the words are there and you need to generate it again. But if you generate it again with the same seed, you're going to have the same output. So you're going to need to change this value here to a different number and try again to see if you can get every word there. So until now, we just generated a shorter take. But what if you need a longer audio? So I'm going to show you how to do this. So first, you need a shorter clip. So in here, we're gonna use 14 seconds and not the 21 seconds. Depending on your computer, you're gonna have to close your apps, so it needs 24 gigabytes of memory free. Then we're gonna add some extra flags. So I have copied the shorter reference and the transcript locally, and also I have a demo of 45 seconds locally. So we can take a look into the demo, and as you see, it's bigger than the previous one. And now that the flags are set, we can prepare our commands and we can run it, but I'll explain you now the commands with the new flags. So again, we are using the same tool, .tts, the same model as before. Now the input text that we want to generate is going to be the 45 seconds one. We see here the difference reference, so the 14 seconds one and the transcript for it. Again, it's in English. And now we're passing long and max chars to 220. So what does this do? So the long part, it splits the text into pieces and generates them one at a time. So this is needed because memory grows with the length of what you asked for in one go. And then we have the max chars at 220 that sets how big each piece is. And as before, we have the same folder where we're going to put the output and the prefix for the file, so long take. Let's start it. It finished generate, and now we can see that MLX peak, so the memory used at this peak, was only 24, so 10 gigabytes less than the previous one. And why was this? Because our reference one was a lot shorter in terms of length than the other one that was 21 seconds compared to 14 seconds. Let's listen to the output. Okay, so here's something I wish someone had told me earlier. You can run a full voice model on a normal laptop completely offline and it costs you nothing. No cloud, no API keys, no monthly bill. The whole thing is about 2.5 gigabytes on disk and it runs on the same chip that plays your YouTube videos. You can hear there was a lot of silence moments. Now we're gonna cut the silences. I'm not quite sure if I'm gonna show you the full one or I'll just cut it in the middle because you can already hear at the beginning that there was a lot of cut moments. So maybe I'll cut the later parts because it's the same as in the beginning. So in order to cut the silence parts, we can use the same script as before. So the post pass on this file, and it went from 86 seconds to 31. So here there was a big difference. So let's take a look into the final one. So the one that doesn't have the silence moments. So here's something I wish someone had told me earlier. You can run a full voice model on a normal laptop completely offline and it costs you nothing. No cloud, no API keys, no monthly bill. The whole thing is about 2.5 gigabytes on disk and it runs on the same chip that plays your YouTube videos. Now, is it perfect? The first time you run it, it feels slow and you have to give it a clean sample of your voice to copy. But once it's set up, you can generate as much audio as you want whenever you want, and nobody is counting your characters. That's the part that changes everything. Now, yes, it sounds good without the silence part. So we just need to do the last check. So is every word there? So if not, we're gonna have to redo it with a different seed. But if yes, we are good. So to do this, we're gonna use the same script as before. So the verify take. And we can see that in this case, it actually doesn't have all the words. So we can see that it's 66 against 65. So there's the no missing. If we go here to the top part, we can see that some of this no, it's missing. It's not on the generated one. So what we can do is that we can run again the command to generate this audio and we can pass a different seed and try again. Or a better way to do this is to identify the exact no that is missing, or if it's a different part that is missing, and generate only that part and then concatenate everything together.